Hi, I'm Gary again, and I just wanted to continue on with our discussion on the fixture plate for this particular product line. So we talked about the critical need for locating the fixture plate to the subplate, and to make sure that that happens repeatable in a repeatable fashion, we machine the fixture plate, and we need to then incorporate two features which drive proper repeatability of location. To do that, there are a couple of bushings that are utilized, and I've got them marked out here to help us know which one to put in which hole. But we have the primary liner bushing, and it is a very close tolerance bushing which helps align it to the subplate. As I talked about before, we'll have one primary location. We have to hold that extremely rigid, close tolerance, so each time we put this plate on the subplate, this diameter gets located to the subplate bushing, so they're very concentric. And so we're going to make that happen, we have to machine this plate. I'll take all these parts out of the way once. And you'll see some different diameters. So we have this diameter and this diameter. These bores will have been machined in to be a light press fit. So what that means is this bushing we have to force into this hole under a certain load, and so it won't slide out under use. We'll do the same thing on the secondary bushing on this end. The difference between the two bushings now is about 1/2 of a thou in diameter. So if you measure the inside diameter of this bushing, it will be 1/2 of a thousandth of an inch, or 5/10,000ths of an inch smaller in diameter than this one. What that does for us is it allows for some variation, temperature change in the plate, machining tolerance, so that the secondary bushing will just be a little bit looser, but just enough to allow us to put this fixture plate on top of the subplate and then install all the ball locks. So when we go to load it in the machine, and we'll demonstrate this again later, this plate will go on top of the subplate, and we can do, and this demonstrates the single minute exchange of die, because as soon as I throw that on top of the subplate, I'm just going to install the 4 ball locks and then tighten them down with a tool such as this. That'll lock it in location because these primary and secondary bushings have fixed it in space properly, and the 4 ball locks will pull it down tight to the subplate to create a very rigid structure to do machining on now. We talked about locating these parts correctly each time and how the clamp is going to work. So we're going to use this edge to locate us in the what we call the X direction, and we're going to use this radius to locate us in the Y direction. So once we get this machine, we'll demonstrate that better, but this is going to get located to 2 spots, actually 3 spots, and then we'll use this clamp to help create a force to keep that part in position. If you look in here, there's a countersink and a slot. So as this screw is tightened down, it's going to want to push the clamp over to tighten up the part against the fixture and withstand any of the machining forces that are happening. So what we're going to do next is show, we have a couple drawings here. We need to create all this geometry inside the fixture plate, and it will be, I'll turn this around so you can see it, all these pockets that you can see that the belt buckles are nested down into. So what I can do now is take you over to my computer, my workstation. We'll quickly look at the solid model of these components. We'll look at the CNC programming, all the tool paths that are put together to create the machining geometry, and then that'll give you an idea of the operations needed to machine the pockets in the fixture plate. And once we get an understanding of that, I'm going to hand over the fixture plate to Chris in the machine shop, and he's going to load the machine program, and we're going to cut some chips. So see you over at the workstation. Thanks.